Good day. This is the ODI Oracle Data Integrator overview presentation. My name is Ancil McBarnett. I've been at Oracle for the last 7 years, working in several different technologies within Oracle, mainly Fusion middleware, as well as recently with the data integration tool sets. And we're definitely going to embark on a journey for the next hour or so, discussing several different aspects of Oracle data integration, and particularly some of its use cases. So let's go right into it. One of the things about Oracle's data integration strategy is that a number of you out there may have purchased or been involved with the previous tool sets, specifically Oracle Warehouse Builder. And as you may have well known, that was incorporated into the database from many years ago. And one of the things about Oracle Warehouse Builder was it was fine-tuned within the Oracle database. You were able to model and create and design the data integration packages, which ended up becoming PL/SQL code for transformations within the database. And if you understand the process or the model behind that, the principle or the paradigm was, can I take data, dynamically create code, and execute it within the database? And if you understand Oracle's strategy, the idea was it was perhaps easier or better or more efficient architecturally to move code to where the data lies rather than moving data where the code lies. And that's a principle I'm going to be harping on and emphasizing through the presentation. However, that was perhaps perceivably one of its weaknesses because it was beholden only to the Oracle database. But it was that strategy that we liked that allowed us to pursue a data integration strategy that says, can I have a data integration platform that can be open, heterogeneous, work beyond the Oracle database, that perhaps doesn't limit its dependency on gateways, yet still be integrated with the Oracle technology stack, be best of breed, and yet be complete. And so perhaps 7, 8 years ago, a company was acquired by the name of Synopsys, which formed Oracle Data Integrator. And over the last 4 or 5 years, another company called GoldenGate was acquired for near real-time data movement. The focus on this actually presentation is on Oracle Data Integrator, but we'll talk a bit on the integration between those two products. The main thing is that Oracle's strategy has not changed. The strategy is, and perhaps this was a strategy before its time, was that what if we can utilize a database, and in this case, not just the Oracle database, but any database as an ETL engine? And in fact, what if we can push the code and dynamically generate a transformations code into that ETL construct? And so this is where the concept of creating a better ETL architecture comes to mind. For those who have worked with ETL, you know that there is one particular paradigm that is at work, which was influenced from the old EAI days, the architecture integration days, where you set up some sort of broker, some sort of middleman tool, and grab data from various data sources. You reach out to tentacles, you connect through adapters, you pull the data into this proprietary tool, which has been tuned and made efficient for transforming data, content routing of data to push back to the target. Just as you see on this diagram, ETL works the same way. You set something up in the middleware, you grab data from its various sources, you grab them in bulk, and then you push it through the engine for transformations. And you preserve a competitive advantage if you are able to transform these data very efficiently, perhaps use techniques as multi-threaded, and push the data to the databases. However, what happens is that even though you've applied or associated this ETL engine with as much memory as you can or cluster it, the data usually is streamed through the engine on a row-by-row basis, which becomes a bottleneck. So if you have to conduct any lookup values or list values or lookups, you do any joins, really, if you don't override any SQL, the components will stream the data and transform the data on a row-by-row process. So for example, you may have 5 transformation elements. You may have 1,000 rows. If you don't do as much tuning, or you don't do any particular strategies that I'm going to mention later, you end up with 5,000 operations on that data. Normally, you stage the data. If the lookup data within the target database, as shown in the diagram, perhaps is pretty hefty, it's larger, it sometimes becomes a bottleneck to load all of that into the ETL to do the transformations on a row by row to push it back. A lot of times, folks end up using bind variables, or they simply just override a SQL, or some do some sort of limited push down of the code into the database, like push down optimization. And so some of those techniques can be applied, but Oracle says, what if I have an architecture that eliminates the middleman, that says I can grab data in bulk, but I don't need to transform on a row-by-row basis or do override SQL or any sort of techniques to mitigate against the issues of transforming into in a memory engine? What if I can push the data in bulk and transform the data in bulk? So the same example of 1,000 rows with 5 transformations, you actually apply all 5 transformations on 1,000 rows at one time. And that's what we refer to in the database as bulk set SQL or set-based operations. And if you know anything about databases, they love the idea of set operations on the database. Now, this was an idea before its time. You couldn't apply this 10, 15, 20 years ago. That's why you need a broker approach, the ETL approach, the middleman approach, because you didn't trust SQL. SQL wasn't mature enough back then to conduct the transformations. OWB did a little bit of this, but it produced PL SQL. What we are talking about here is the idea of generating pure SQL and SQL that is tuned for the database platform that you find yourself running upon. So this can be Microsoft SQL Server, DB2, Netezza, Teradata, Greenplum, whatever database platform you find yourself in. The paradigm is, instead of using an engine-based approach, we use an agent-based approach. So it's lightweight, and it's tuned for the database platform that you provide yourself with. So for those who are thinking ahead, you could see that this is the precursor to big data. The idea that you have a large data lake or data warehouse or data reservoir, you can put your data there, and you do not expect the data to move a lot out to conduct transformations. What you rather do is push code of transformation logic, which is much more lightweight than the actual data, push it to this data reservoir or lake, and conduct a transformation. If you have a large lookup data or dimension data or fact tables within the database, and you're able to accomplish that with the myriad number of SQL analytics functions that are found in the database, then let's do that. And so that's the paradigm behind ODI, and it's very important to understand this. This is the architecture that Oracle sought to go after, as opposed to the architecture that you may be accustomed to within the current ETL space. So what you find then is we're able to leverage this lightweight agent-based architecture that does what you potentially could call push-down optimization to the max, to do something called next-generation data warehousing or real-time data warehousing. Now, while we may not be going into depth into the other piece of Oracle's data integration strategy, which is GoldenGate for real-time transformations, I'm just going to introduce a little bit on how they can work together for this unique use case of bringing data in a timely, low latent, but performant fashion from various sources. For example, if you have various sources and you have the use case or requirement where if transactions occur on my various applications by sources, I want that applications to be captured, and I want it to be transformed in incrementally. I want the changes to be captured. I know I have a lot of transformations to do within the data warehouse or my operational data store, but I want this to be done in a near real-time fashion as opposed to waiting on a batch basis, perhaps nightly at midnight or 2 a.m. in the morning to conduct this and grab all the changes that occur during the day, as opposed to perhaps running this maybe every 2 hours or 1 hour. What if in a continuous incremental fashion, I can grab data, and we would use Oracle GoldenGate to capture those changes from the various sources. And because ODI is an agent-based approach, similar to, akin to, like an Oracle listener on a database. Think about it like that. It's a listener for data integration. What if I can just transform the data as changes are pushed from GoldenGate and captured, and just transform on the fly to this data warehouse schema? A number of companies have adopted this. In fact, we have one particular example where end-to-end, the SLA requirement was to conduct this in a matter of 10 seconds or less. And this is for a large financial firm. So this is some of the exciting things that have been happening within Oracle, where because of our lightweight approach, the approach where we understand the paradigm is push the logic where the data lies, understand that we can do the best of breed from data capture, as well as utilize any database platform for transformation. The possibilities are endless. So that gives you a little bit of a taste on how you can combine these data integration pieces together, offerings within Oracle, and some of the strategy and thinking behind Oracle's data integration strategy. So let's take a step back now and understand Oracle Data Integrator itself and some of its capabilities and how can it be applied to certain use cases. To round out the data integration stack, we introduced a bit Oracle Data Integrator. I talk about that as the agent and an engine-less approach to data integration using bulk set transformations. SQL generates SQL. And by the way, it can generate not just SQL, but really it has the potential to generate any type of code. Python, Java, Groovy, soon Pig for the big data platform. Ideally, it's an approach where you transform data using the database platform that's available to you. Oracle GoldenGate for near real-time data replication and change data capture. And this is a very subtle point because sometimes within the data warehousing world, folks may say, I don't need real-time transformation. I don't need to get my data in real time. Well, really what this brings to the table and GoldenGate brings to the table in the data warehousing world and even beyond, it's not just real time, but the main thing is change data capture. Allows you to not resort to strategies such as creating triggers or depending on timestamps or any type of strategies for capturing changes. And so that's where within the data warehousing world, GoldenGate really has proven very well in this infrastructure. To round up the stack, we have our enterprise data quality solution. So when you want to do name address matching, merging of customer data specifically, conduct any regression expressions, look at frequency of data, pattern recognition. You want to ensure that all your phone numbers are of the same construct, same patterns. That's where Oracle Enterprise Data Quality comes in. Finally, we do have Oracle Data Service Integrator, and that's for the federated query approach. The idea there is that this is a unified tooling for both structured and unstructured data, can be optimized for database platforms, but especially for the data appliances, and we will talk about that later within this presentation, Netezza, Teradata, and especially Oracle Exadata. And being Oracle, we have extended support for applications within the Oracle ecosystem. So, we touched on this, but why ODI? Why Oracle Data Integrator? Number one, it employs a next generation architecture. lowers your total cost of ownership, but you don't need to stand up a middle infrastructure for transformations. You can do that within ODI if you wish, but preferably we would like to either transform either at the source or usually at the target. So you're very flexible in your architecture, and you can optimize it for performance. If you think it's better to do some joins and SQL and filter the source and dynamically send that data across, lowering network traffic, send it to the target. For any further transformations, you can get that done. Again, it leverages set-based transformations. So when you're on the Exadata platform, or on Oracle Database, or on a Teradata platform, and you know you need to use T-SQL or N-SQL or Netezza, you just generate the SQL for those platforms, which improves performance for loading and transformations and take advantage of existing hardware. In addition, the way in which it conducts these transformations is pretty unique. In fact, if I use a silly analogy, if you look at the idea of GPS today and the navigations today, and you move from, perhaps you decide to move from a source to a target, you're leaving from one particular jurisdiction to another destination. Conventional ETL is, as follows. You provided a toolbox, you provided a whole bunch of icons, and you create your roadway to get from your source to target. So you lay down your asphalt, you have an icon or for joins, so you put down your traffic lights, you turn left to right, you actually lay everything down. You become a complex ETL developer to create transformations all the way from source to various targets. But what if you do have those components, which is fine, but you have the ability to decide, well, I'm going to the supermarket today, I'm at home, I do need the traffic lights, I do need the infrastructure, I do need those components, but what if I decide I'm going to put something in an address, and that thing spits out to me the map, the directions, the longitude and latitude, and creates actually an easy way in which to say, here is how you get to that destination. Well, that set of maps within the GPS is akin to ODI, Oracle Data Integrator. Those maps we refer to as knowledge modules, which creates for improved productivity for developing these constructs. For example, you know that you want to move data from SQL Server to Oracle. You want to leverage the BCP bulk loader or bulk unloader in this case. Well, you create the journey. You say, I want to go to SQL Server to Oracle. You create your mapping. You decide these are what you want to do for joins. This is what you want to map from a source to target. But then you just apply a map. It's like going to the GPS and saying, I want to go to this destination. Here's a detour. I want to use BCP and SQL Loader. I don't want to use just normal JDBC and select. That's the type of thing you can do, where you just design what you want, and the data flows are automatically generated for you using one of the 140 knowledge modules that's available out of the box for any sort of data integration scenario. This significantly reduces your learning curve and shortens implementation time. And so, as I mentioned, these are the knowledge modules that come with ODI, and in a sense, it's the heart of ODI. The fact that if you run up against DB2 and you need to use a DB2 loader or unloader, or you want to go against Netezza and you want to use the Netezza utilities, NZ load, or Teradata, or Oracle utilities, external tables, you want to load from flat files, or you want to reverse engineer from certain constructs. The idea that you have these code templates where you don't have to reinvent the wheel every single time you develop a mapping, this is invaluable to you. So we do have out-of-the-box mappings or templates for the Oracle product, obviously, for Oracle ecosystem. eBusiness Suite, for example, you need to dump data into interface tables and call the concurrent programs and be able to handle the batch IDs and group IDs and all the stuff that is unique to Oracle eBusiness Suite. Well, guess what? There's a map for that. There's a knowledge module template for this. Oracle Spatial for Siebel. Using DB links, you want ODI to create DB links on the fly based on you going from Oracle to Oracle. So it makes sense to do so. Perhaps create these DB links on the fly or utilize existing DB links. Utilize that and perhaps create a merge statement. So you just incorporate, you do your logical design, you conduct your logical design, and you create, you tell ODI, I want to use the merge strategy because that's what I want to incorporate when I want to land data to the target. But also for non-Oracle platforms, you have these similar templates available to you, whether it's for SAP to generate a BAP code, or even Salesforce to connect to Salesforce APIs for moving data out of Salesforce into Salesforce. So I hope you begin to understand some of the architecture benefits with ODI. Number one, it's an agent-based approach. It utilizes the platform that's available to you. Number two, you are able to push the code and dynamically generate the code unique for that platform. Number three, you have templates that powers the generation of this code. And these templates are extensible. So you're able to crack them open, nothing is a black box, generate these templates based or extend them based on unique requirements. This leads to faster development, lowers the time to market, and you can create the best practice for your organization utilizing these templates. One of the things that feedback that I've gotten from a couple of customers, it says they love the idea, this approach, because it promotes governance. Any two developers, or any two ETL developers can sit and can create the same mappings, and because they utilize these knowledge modules, you're guaranteed that the code generated will be the same every single time. Unlike on the conventional ETL approach, you're beholden to the constructs of that ETL developer. How did he decide to do the join first and something else later? And his approach in getting that done. And so you are able to have a uniform and predict how things will be executed, and lowers your cost of ownership within Oracle Data Integrator. So we talked about all the various types of connectivity. Big data, we support both Cloudera and Hortonworks for generation into Hive, HBase, and really to produce MapReduce code within the big data ecosystem. We talk about how it's best for Oracle. You can take advantage of any of the hints, any of the parallelization, any of the constructs with the Oracle database, as well as in other databases, actually. It's best for CDC, changing the capture, and I will talk a little bit about that. I introduced also the fact that we have templates specifically for Oracle applications, and even for non-Oracle applications, such as SAP and Salesforce, and really it's heterogeneous. So unlike what we had before, it's not beholden to the Oracle database per se. You can use this even if you don't have an Oracle database within your ecosystem. So whether you have all DB2 or SQL Server or any of the major RDBMS, you can utilize this product for your data integration needs. All right, so what we're going to do is spend some time for the rest of the presentation discussing some of these use cases and how would you apply Oracle Data Integrator for your specific use case. And hopefully, perhaps one of these use cases would be something that you are looking into for more information. So by way of recap, we talked about where can Oracle Data Integrator be used as a very optimized ETL architecture. And really, we like to use the term ELT architecture to distinguish it from the traditional approach, where you can extract, load, and transform. And of course, for conventional heterogeneous data integration, for near real-time data warehousing, where perhaps someone may have a strategy that leverages taking data from various sources, putting it into an operational data store, and then from that operational data store, that can be spinned off and pushed downstream to other applications or to the data warehousing. For mainframes approach, so we have ability to capture from vSAM, be able to peruse and transform episodic type data. can be used for migrations and consolidations, even in addition with Oracle GoldenGate for zero downtime migration. And you can use GoldenGate for zero downtime migration, and then when you need to have dissimilar schemas that may be beyond the transformation capabilities within GoldenGate, you can utilize ODI to transform dissimilar schemas for upgrade or for migrations. You can use it within the SOA ecosystem, and this is one of the powerful use cases within ODI. Every single job within ODI automatically is exposed as a web service. You don't need to do anything extra. And so you can leverage this within your SOA ecosystem, and in fact, you can assist SOA when it has to conduct bulk transformations of data. Instead of limiting SOA to transform data perhaps over 5 megabytes and over, or trying to incorporate transformations that are better utilized in a database, whether it's lookups or joins, etc., you can utilize ODI and call it through SOA. And of course, traditional master data management, single source of truth, data quality, Oracle Data Integrator can be used within all those various use cases. So I want to highlight specifically a few. One, real-time data warehousing. Let's go into that a little more in depth. This is something that folks are looking for, and we realize it's more than just buying a CDC tool and slapping it in front of an ETL tool. In fact, a lot of times people emphasize the nature of the connectivity. Well, we support messaging between the CDC and ETL, or we support this, and so the focus is on the connectivity, and they forget there's a whole architectural approach under the covers beyond just the connectivity. If you just focus on the connectivity, or if you think it's just a matter of buying a CDC tool and slap it from the ETL tool, you may be in for a rude awakening. There's a lot of architecture that needs to be done under the covers, so you can do perhaps pub sub models. You can handle purging of the data. You can handle purging of you can handle even when you get a change and you realize to transform to a fact table, the information within the change of the data is not sufficient. You may need to do a join. You may need to perhaps go back to the source and get additional data to augment your transformations, which might end up defeat the CDC approach. Why get a change date record when you have to join to go back to the source to get additional data to do the transformations? So what I want to do is walk you through how we can use ODI and GoldenGate together in this approach. Normally, you have your transactional RDBMS. Your users may be saying, we're tired of taking the hits anytime we need to have ETL done. It slows down applications. Or operations may say, well, our windows are shrinking. We no longer can guarantee that we have all the data moved if we start from 2 a.m. in the morning. By the time you come at 8 a.m., the process is still happening. So you set up some target tables, which may be similar or dissimilar, maybe a data warehousing. And the first thing you may need to do is create those target tables and populate them using various approaches, whether transportable databases, or you can use even ODI, tablespace, or ODI to transform and populate those tables. Then you set up staging tables. You instantiate staging tables within the staging database. This can be within the same database as a schema for the operational data store. It could be a separate intermediary database. So as I mentioned, you can use ODI to instantiate the target tables, do the necessary transforms. And this is really the value for the integration between ODI and GoldenGate. As I mentioned, it's more than the nature of the connectivity. Some will emphasize we connect through queues. Quite frankly, I can make an argument why queues, while they're important for certain levels of performance, falls down with respect to reliability at times. The architecture we're promoting is one that tunes for performance as well as tunes for reality, reliability. If you know anything about computer science 101, anytime you tune up for performance, sometimes you have to sacrifice reliability and recoverability. And anytime you tune up for recoverability and reliability, sometimes you have to sacrifice for performance. The Oracle's approach is, what if we have both turn up to the max? So we have the idea where we stage tables and we incorporate a framework, a CDC framework, and whether this is something you'll have to think about doing anytime, whether you use a tooling or not, you have to think about, where am I going to store these changes? Am I going to be using triggers? Hopefully not. When I have all these journaling or my inserts or updates queued up, how am I going to ensure that I can grab those and do whatever joins or transformations I need to put it to the target? And so this is what is set up, the entire CDC framework. Suppose I want to do some publishing and subscribing of that data. I grab the data from a particular source, but it may need to go to my order management channel. It may need to go to my internet channel. It may need to go as flat files. And I have to ensure that the data is not purged until all those subscribers grab that data. So that's involved with the CDC framework. So you set up GoldenGate. As I said, this is beyond the scope of the discussion. We do have another recording specifically on GoldenGate. But you set up GoldenGate to capture the data and creates, queues that up into source trail, in some trail files. Then that data is replicated to the staging, and then it creates journal entries into the change data capture framework. And this is very important. One of the things maybe the analogy I can use is, suppose you know that you are away. I travel quite a bit. You come back home. You have a bunch of mail that you need to open. So that represents changes of data. Suppose your significant other has already tackled that. They've opened the mail. They have applied the transformations. They've paid the bills. They've done whatever is needed. And so within the stage in the operational data store, that's as if the data has already been applied. It's already been updated, has been deleted. Now, it's kind of tough for you to unravel back to figure out where was the exact update or delete, because just replicating the data is nice, but you need that information because that helps you understand how to do the transformations later on to dissimilar to fact and dimensions table. So just understanding what actually changed and being able to do the transformation without going back to the source, especially when the transaction itself doesn't have enough to tell you what you need to transform to the target, this is where it's important. So in that mail analogy, you hope that somebody writes a note or journal, I paid this bill, this is the amount, I paid this electrical bill, so that you can do further follow-ups. And that's exactly what the framework does. It captures these journals. The data has already been applied on the staging. So, for example, if you have 10 inserts, well, let's reverse it. 1 insert and 10 updates. Okay. Instead of trying to as in traditional CDC, you look at all the updates and then you try to figure out which one wins and based on the last update date, etc. Well, in this infrastructure, you queued up all the primary keys. These are what occurs. So you may have in the journal entry 10 entries, 1 insert and 10 updates, but only of the primary keys. You know the last update was already applied to the database. So you basically just do joins within a particular window ID for consistency sets to grab the data to the target. Now I'm simplifying the process. But the whole idea of consistency sets, window IDs, all of that is available, and that's what comes out of the box with the CDC framework. The point is, you don't have to do this yourself. It's more than just slapping a CDC in front of an ETL. And then you put them all together to transform. So if you want to create this on your own, this is what you need to do. This is the entire CDC infrastructure. And this is the rude awakening I was letting you know about. If you just simply buy a CDC in front of an ETL, you begin, and then you realize, well, I need to have consistency sets, so I create views, or I need to extend windows. I don't want to depend only on timestamps. I'm missing deletes. Oh, I need multiple subscribers. I need purge operations. That's the rude awakening. That's the architecture that comes out of the box with ODI and GoldenGate. So Oracle has put a lot of thought into this. So why is ODI and GoldenGate better together? For performance. It's the fastest real-time integration with the fastest bulk integration. And then we don't sacrifice reliability. You have many options to replay and recover transactions. If something happens in the target and they want to recover, if you have a queuing mechanism, it's tough to go back to the queue to get the information. Most times you have to replay the transaction from the source to push it all the way through the ecosystem. Here, you can replay the transactions from the journals within ODI. If that's not available and it's already been purged, you can recover from GoldenGate trail files. At the last resort, you can replay the transactions from the source. And this architecture is fully defined, fully extensible, and it's pretty strong. It's a strong differentiation. Okay, so let's round up just a couple more use cases. Oracle Data Integrator with engineering systems. We saw this is an extension of the near real-time data warehousing that I mentioned. You have GoldenGate that's doing near real-time feeds into a staging area within the database. You have ODI that does the transformations into fact dimension tables or into analytical structures or OLAP. And if you use Oracle Exadata, the performance cannot be matched. In fact, I've had an example where within a client, they were looking at a conventional ETL system, using that in front of Exadata. They got some gains by reducing a process from 12 hours to about 5 hours. From 5 hours, yes, from 12 hours to 5. But then when we put this in front of ODI and utilize ODI to do the transformations, we actually were able to reduce the number of steps, and I believe it was about 18 steps, reduce it down to about 6 or 7. So the number of steps were reduced, and then utilizing Exadata and the power of Exadata with InfiniBand and FastScan, we were able to reduce that processing from 5 hours to 7 minutes. And so that was a tremendous achievement there. Simply because instead of moving the data to where the ETL was and doing a lot of round tripping between the ETL and the database, because you got to put data in, pull out lookups, maybe push data in, hopefully you can reduce that with whatever staging or hashing or stuff you can do, or even push down. But yet, think about ODI as push-down optimization on steroids. Another use case, Oracle Data Integrator with business intelligence. Again, you extend the underlying architecture that now you're used to. Your application will still be running on your sources, but you can have real-time business intelligence on top of the ODS or staging framework. And then you can have analytical business intelligence for all the transformation, the results of the transformation in a target. And so this is some of the architecture that I'm exposing to, or some of the use cases, and how can you apply the next data integration architecture to several use cases. In fact, this was the foundation behind the architecture behind our BI apps, our recently released business intelligence applications from Oracle that is now fully based on Oracle Data Integrator. And you have also a GoldenGate option for streaming that data into the BI apps. So if you need to know more about this, we have several resources on our Oracle websites and Oracle Technology Network that explains this. Also, to round up this use case with the business intelligence, you're able to conduct a source to presentation data lineage. So you can look at a particular dashboard, understand the data and trace the data and the transformations that feeds that dashboard. Okay, a couple more use cases. ODI with big data, and big data is all the rave. We understand, some of the disruptive technology that big data represents. And really, it's nothing new for ODI. The fact of the matter is, it's just another platform from which we can run transformation logic upon. In this case, it will be MapReduce code. It will be Hive or HiveQL. And soon we'll be supporting Pig, and whatever else is there, whether it's running on Hive, whether it's running on Tez or Spark, being able to use the Hadoop ecosystem. And that's the thing about the ODI. Being able to use this without resorting to different technologies, different components, it's the same tool for transforming data within ODI, within Hadoop, or ingesting data from various sources into Hadoop. You could utilize in Scoop, or potentially utilizing even GoldenGate for near data capture, real-time capture from sources to push into Hive or into HBase or HDFS. And for fast loading, specifically into Oracle, for one, we created an Oracle data loader for Hadoop that can be utilized by ODI for fast loading into Oracle, and especially Exadata to take advantage of InfiniBand, as well as to other different targets, utilizing Scoop and other technologies. So the takeaway is Oracle Data Integrator is best suited for this particular, for big data. And you can utilize all the constructs in big data for push-down code and logic. In this case, it doesn't have to be SQL into the platform. So you're provided a visual way for modeling big Hadoop constructs and objects, simplifies the code generation, and utilizes a number of the industry standards within the Hadoop ecosystem. And it's one tooling for structured and unstructured data. So we also provide connectors. If you look at the Oracle, for loading into Oracle Exadata, and even potentially using it within the Oracle Big Data appliance or not. And so of course, the Oracle Big Data appliance is an offering we have that packages big data out of the box, and that's something you can definitely reach out to us at a later point in time for any more information on that. Okay, a couple of more. ODI with SOA. You know, SOA plays very well for an application-to-application integration, especially when you have messaging and XML formats. ODI, as we mentioned, is for data integration at the database tier. But there are times where there's an overlap. You may have larger XML to transform, and larger meaning over maybe 5 megabytes or more. Or the nature of the transformation doesn't lend too well to X-queried XSLT. It might be better if you land the data and do a lookup, do some merging, do some SQL constructs to transform that data. And that's where utilizing ODI within SOA infrastructure comes in very handy. So this shows that ODI is just simply a service on the bus. Okay, it's just part of a unified platform. And once we've done that, we can incorporate ODI to do bulk data processing. So you alleviate SOA from the issue of taking batch loads or maybe unloading large XML or transformations, or even if you're going from database to database, expose that as a service. And then at the same time, ODI can give feedback to business activity monitoring, so to update your key performance indicators, to the event delivery network, for the human framework interaction, for approval and rejection. So there's a number of use cases that is applicable that I just want to touch on, but beyond the scope of this presentation. Okay, so finally, let's touch on Oracle Data Integrator with data warehouse appliances. We spoke about Exadata. It's best for Exadata. But we also are pretty good on top of Teradata. And so here is an architecture where that it's better to utilize the Teradata and its nodes for all the transformations that are necessary. Teradata uses certain utilities to load data in. It's best if you use certain utilities like tpump, etc., or TD utilities. If you set up a utilities box with the client utilities set up, you can install the ODI agent of that box. You can have a repository there or elsewhere. And the idea, you can load from flat files, call the appropriate utilities, or load directly from different sources, have ODI push that data and stage into Teradata, and most importantly, in addition to a replacement for BTEC, you can have ODI transform data using native T-SQL or SQL for Teradata and its analytical approaches within the box. That's very, very powerful. Okay, so this shows an example where you maybe could use GoldenGate to replicate the data directly onto Teradata, and then have ODI engine just transform the data within the box. So these are several successful strategies that you can use within the Teradata platform. Lastly, let's talk about Netezza. It's a similar approach. You can load flat file, use nzload, and similar for Greenplum, GPF disk. Load data into the platform and conduct the transformations that are necessary. So again, you set up a box, you deploy your Netezza client utilities, nzload, whatever you have to, put a listener there, an agent on that box, have it listen for the flat files or grab data from the various sources, push it onto Netezza where in the methods that Netezza would like. For flat file or for changing the capture, you can utilize GoldenGate. GoldenGate, with the use of the flat file adapters, can produce the flat files that are necessary and grab the data and let ODI call nzload, jump the data into Netezza, and then conduct the transformations within Netezza. Here's an example where, without using flat file, GoldenGate can be listening for changes on the source, can just do journaling alone and keep track of those journal entries, and then ODI can listen to those journal entries, join and do whatever it needs to do to grab the latest data and push it into Netezza. Okay. Finally, if you don't want the journal entries to be done in the source, the journal entries are done in some staging ODS schema. One customer is doing this where they have an operational data store in front of Netezza. And so you have GoldenGate pushing the data to an operational data store. I believe in this customer use case, the operational data store was SQL Server. And then push that to Netezza as the case may be. So I know I've gone through very quickly certain aspects of ODI, but I hope you get an appreciation of the nature of its unique architecture. The fact that, with this architectural approach, it can lower your total cost of ownership, get better ROI. You're not wasting time on a lot of scripting and needless ETL mappings, and it's actually reduced the number of steps you have to code, especially with its template approach, its data governance. And it's actually simpler to do a lot of this ETL. The fact that, just as how you get the benefits of when you're driving to destinations, you have a GPS. Yeah, you can look at a map. Yeah, you can scribble and write everything, all the directions. But just the fact that you can actually punch something in, apply a template, and it spits out the code, and you can extend that, that is a great benefit. And quite frankly, it's very fast. I've done a number of these, not implementations of bake-offs with a tool. And quite frankly, I have not had anything else that beat ODI in terms of poor performance when you apply it on a particular platform. So its architecture is unique. It's able to leverage integration with Oracle GoldenGate for near real-time replication. And that forms the basis for some unique approaches with several use cases, whether it's real-time data warehousing, approaches with Exadata, engineered systems, with other data warehousing platforms like Netezza, Teradata, even Pivotal, Greenplum, as well as within the SOAR ecosystem, business intelligence. So there are a number of different areas in which you can apply Oracle Data Integrator. So if you need to have more information, it's there up on the screen. You can join LinkedIn. There's a very healthy discussions and healthy group within LinkedIn. You can search for that. Facebook feeds, Oracle forums. We have a couple of books out there. You can search within Amazon for the Oracle data books. And we're happy definitely to answer all your questions. So with that, thank you for your time. And thank you for allowing us to give you a great overview of Oracle data integration and data integration within Oracle's ecosystem. Thank you very much.